but you can see there is still improvement that we can make. So let's going to make now this improvement by letting the algorithm, the classifier, to have to not pass through the origin, even if we are not here adding specifically a constant term. We can do it. It would be more efficient even to just allow the classifier to be parameterized by the various parameter plus a constant. Instead, here, just for simplicity, we employ the trick to add one dimension to the data and fill it all with ones. But it will be less efficient than adding a constant term directly to the classifiers. And then the second important things that we will do is that, if you notice here, in this function here, we run through all the data sequentially, but something that we can do to improve is to go randomly through the data at each epoch. So we'll make this function a little bit more stochastic by adding the fact that we'll go random through the data. And third and important improvement is that when you have this function here, you need to remember how to run, which parameter to give, and also what it returns, this function, that the function returns the parameters theta. So this will be specific for the perceptron origin. And well, many machine learning libraries employ a little bit different organization of the code, I would say. But instead of having a different function with different parameters, with different things set up in the output, we have the same structure, overall structure of the functions, and we just specific for the model a different structure. So here we have some supervised models as an abstract type and training options again as an abstract type. And now we're going to define one model, and we call it Perceptron, that is a child of supervised model. And here we are going to set the parameters specific to a perceptron model, but we may have another model that is random forest that has completely different parameters. But important is that these are supervised models. And at the same way, we create a structure for perceptron training options specific for when we train in perceptron models as a child of training options, where we set all the parameters of the trainings, and we make here a constructor in order to specify, to not having to specify all the options every time, but we make some default options here, in particular with only one epoch, no verbosity, and no shuffling of the data. At this point, we can create one generic function that we call it predict, and we will have predict for all other kind of models. In this case, we create a predict where the model is specifically perceptron. I recall you that in Julia we have a multiple dispatch, so we can create a function with the same name but with different types of the arguments. So here this function will take as specifically as argument a model of type perceptron, and will take also the features of the data that we want to predict. So it is here at this level that we add to the x the constant term 1, and we will run the prediction will be the dot product between the future vector and the parameter of the classifiers. And in case that this one is higher than 0, or more correctly higher than a value a little bit higher than 0, we return 1. Otherwise, we return -1. So here is a ternary operator. So you read this one. If this is true, do this expression. If this is false, do this expression. So return -1. So this one predicts a single record, and you can see that X here is an abstract vector. We can make the same predict functions, but when we have a whole matrix, and we run this function here for each record. So this predict here works for the single record, and this predict return a vector of predictions. We then have our update functions. Again, the update is with exclamation mark, because it will change the first parameter, that is the model, because we are going to change the parameters of the model itself. So this is why we keep the exclamation point in the name of the functions. And the update, of course, will take the model, will take the X and the Y, and as before, we add a single one at the vector of the X, and then we modify the parameter by removing the future of the X multiplied by the label. At this point, we are ready to make our train functions. Again, train with an exclamation point, because it will change the first parameter, that is the model itself. So what we do here, we pass to the train function, and this will be something very similar to all supervised models. We train with the specific model. We train giving the X and the Y, and we pass the training option in this opt argument. Here we retrieve the epochs and the verbosity level. We add one dimension because we are for the not here, but we are still doing something inefficient here, because these functions go through all the epochs and through all the records. However, if the set is linearly separable, at a certain point we may find a perceptron that classify correctly all the points, and at that point it will no longer make any update, so it doesn't make sense to continue through all the epochs. But we could set another variable here, errors by epoch, and when we realize that we have no longer errors in an epoch, we can just return the function and terminate before going through all the epochs here. So let's go into test our new training functions, and we are going first to create our model with all 0 with one dimension more than the dimension of X to account for the intercept, the constant term. And let's go into choose starting with options without shuffling and only one epoch. Let's train and visualize. So here is our classifier. It doesn't pass anymore for the origin. You can see it's much better. Let's go into compute the value that it predict and compute its accuracy. And to compute the accuracy, what we do is that we compare the outputted value of our classifier with the real labels, and if they are equal we get a 1, and so we sum them and then we divide by the number of records that we have. So here for 89 out of 100 cases the result is of the classifier is correct. let's see if shuffling and increasing the epochs may also increase the results further. So we just change the options to add more epochs and shuffling, and we reset our model and we train it. As you can see, it's very fast, and here we can see that the accuracy even increased to 92%, but attention that this accuracy is the accuracy made over all the data.